So we're beginning chapter 5 today, even though we haven't taken your chapter 4 test. Your chapter 4 test will be tomorrow. Quiet. Part of the reason we're doing this is because we don't give tests on Monday. Just kind of not cool to give a test on a Monday. Okay, so it kind of, okay.
You could give us a test on Monday if we go quiet.
Guys, thank you. So generally, as a rule, we don't get tests on Monday. Just one of those things. We are going to go ahead and do the notes and lesson for chapter 5 for 5.1 to kind of make sure that we get everything we want done before the end of the semester. We want to get through chapter 5, and I think we're going to start chapter 6, but I'm not positive if we're going to get to 6 before the end of the semester or not. Chapter 5 is about lines and writing equations of lines and graphing lines and lots of stuff with that. So today we're beginning with rate of change and slope. And the first definition, rate of change shows the relationship between two changing objects. A lot of math is about measuring change, how fast things are changing, how fast something is growing, how fast something is shrinking. It is arguable that calculus is nothing but talking about change. Okay, when I teach calculus, that's all it's about. It's about rate of change and comparing rates and finding rates and figuring all that out in new and fancy ways. But how fast something is changing is an important thing to be able to find. This is an introduction to that. Slope is the rate of change of a line, vertical change over horizontal change, rise over run. When you think about slope of a line, it's rise over run. How much something goes up over how much something goes over. This is a big part to remember right here. Rise over run. Slope equals rise over run. Okay, as a line goes up, how much does it go up over how much it goes over? And we do have a property, or I should say a formula, for finding slope from two coordinates. You have 2 points, change in y over change in x. Okay? Which makes sense. Change in y. How much you go up and down on the y-axis, that's your rise. Change in x. How much you go back and forth, that's the run. You rise up and down, you run back and forth. Rise over run. Y over x. That's how I remember. Change in y over change in x. So if you have 2 coordinates, you do the y-coordinate minus the y-coordinate over the x-coordinate minus the x-coordinate. And that gives you the slope of the line passing through those 2 points. Okay. Now, there are 2 special lines. First one, we have no rise. It doesn't go up or down, it just goes flat. Okay? So if our rise is nothing, over number, 0 over number, that's okay. 0 can be in our numerator. That's a slope of 0. There's no change in the rise. It has a slope of 0. So this one right here, this example, our slope is 0. Horizontal lines have a 0 slope. Okay. Vertical lines, they have an up and down, they have a rise, but they have no run back and forth. There's no change in the x's. Then I have a 0 in my denominator, which I'm not allowed to have. It's undefined. So this one here, the slope, you can either say that it's undefined, UND, undefined, or this is also called a no slope. There is a difference between a 0 slope and no slope. A 0 is a measurable amount. No slope means you can't measure it. There's a difference between the two. Here you go. That's as far as I can go. Oh, you meant the other up? I did go up. It went up. The thing went up. You mean to scroll down so I can get up? Yeah, I wrote this formula over here on the board. And I'll put it up here again on your notes too. But okay, we're going to do the points, finding slope from points in a minute. But here's something. Students get hung up, always get hung up on the order of your x's and y's. They see the formula, y sub 2 minus y sub 1. Oh, it's got to be the second point minus the first point. It doesn't have to be. It could be the first y coordinate minus the second y coordinate over the first x coordinate minus the second x coordinate. That will also work. It doesn't matter which point comes first. As long as the x coordinate and y coordinate that line up vertically come from the same point. Students, oh, well, you did it wrong. It has to be the second one. No, it doesn't have to be the second one. It can be the first one. Okay. Excuse me. Okay. Problem number 1, finding rate of change using a table. The table shows the distance a band marches over its time. Is the rate of change distance with respect to time constant? What does the rate of change represent? Let's see if I can move this. Oh, I can. Yeah, isn't that cool? I love this. I used to not teach with the smartboard. Oh my God, I'll never go back. I'll never go back. Okay, so, I'm going to need to get a calculator out for this one. Yes, I have taught off of a chalkboard before. Yes, I have.
Do you ever scratch it?
No, I can never quite get my fingernails to work that way. Okay, so here's what we want to do. We want to figure out the slope. We want to figure out the change. So what you're looking for is my change constant. What do I do to get from 1 to 2? I go up 1. To get from 2 to 3, I go up 1. To get from 3 to 4, I go up 1. Gentlemen, thank you. The other one, I want to see if it's the same way. So what I got to do is I got to do some subtraction here. First, I got to turn my calculator on. Just let that, there's the button. Okay, so 520 minus 260. And this one goes up 260. Does it go up the same amount on the next one? 780 minus 520. Ooh, it's 260. Now, do you think the next one's also 260?
Yes.
But what do we need to do? You need to make sure. You can't just say, well, it was on the first two, so it's got to be on the last one. You'll want to make sure it is all the way. 1040 minus 780 is, yay, 260. Okay. So, they are constant. The change is constant every time. How much, which one of these is my y, which one's my x? Yeah, this would be my y, this would be my x. This is how much my x is changing. This is how much my y is changing. So my slope would be 260 over 1. Change in y over change in x. Rise because it goes up and down. The y goes up and down. Overrun, which goes back and forth. It's always y on top, x on the bottom. Yes?
Can it be 1 on top and on bottom?
No. No. It would be negative if it was going down. If this was going down each time, let's say these numbers and just these numbers were flipped on this side, it would be going down 260, then it would be a negative slope. This has a positive slope, goes up. If I were to graph this, it would look something like that. positive slope going up left to right. A negative slope would be going down as I go from left to right. Okay, so that's what the difference is between the two. Yeah.
And why can't one never go positive?
It's always rise and run. How much something goes up over how much something goes over. X's goes back and forth. My Y's go up and down. That's why it's always the Y's on top and the X's on the bottom. Always. It has to maintain the same one every single time. Okay? Problem number 2. Finding the slope from a graph. Now, finding the slope from a graph. On your homework, or I should say your classwork today, you will have graphs with lines on them. You will not have the nifty little arrows like this one does. You will not have the coordinates like this one does. But what you will have is you will have a line on here. Find 2 places where the line crosses at a grid. That's what you want to do. You don't need the coordinate points, but what you do is you need to connect those 2 points by drawing a triangle. How much you go up, how much you go over. I go up 2 units, and then I go to the right 3 units. So my slope, how much do I go up? I go up 2. How much do I go over? I go over 3. So my slope of that line is 2/3. If I do the same thing on this one, here's my 2 points. Go down, go over. So my slope, I go down 4 units. Down would be negative direction. So I go down 4 units and to the right 5 units. My slope is negative 4/5. Okay. If you have a line going up, it should be a positive slope. If you've got a line going down, it's a negative slope. One of the things that students will do is they will count both as negative. You can't do both negative because 2 negatives give you a positive. Okay? And if you want to have an idea, this is just a quick check. Am I even doing it right? If you were to do this one and get a negative slope, that'd be wrong. If you did this one and you got a positive slope, that would be wrong. That's your first check. Even without knowing the numbers, just whether it's positive or negative, you want to watch that. Okay? Any questions on this? You won't have the coordinates. You won't have the arrows. You have to draw that little triangle in yourself and just count the squares. 1, 2 squares, 1, 2, 3. That's all you have to do. Okay. This one you're going to use the formula. Okay. Now, my slope is equal to, that part never changes. It's always subtraction. And I'm going to do the first point, 1, 0 in red, and use the point 3, negative 2 in green. So it's y-coordinate minus y-coordinate in my numerator. So my y-coordinate, in the first one I have 0, and the second one I have negative 2. The x-coordinate in my first point is negative 1. The x-coordinate in my second one is positive 3. Plug in your y-coordinates, plug in your x-coordinate. Notice, and this is the important part, the x and y here line up vertically. The x and y here line up vertically. And then I simplify. 0 minus negative 2, well, that's the same thing as 0 plus 2. So I get 2 in my numerator. Negative 1 minus 3 is negative 1 plus negative 3, which gives me negative 4. And what do we always do to fractions? We always simplify, always reduce. So this is negative 1/2. Y minus y over x minus x. Now, I have students that will say, Mr. Horace, you did that wrong. Because what did I do wrong?
Isn't this point negative 1 0 is that y or
That's what I'm getting after. And that's the point I wanted to make about this, is that technically it doesn't matter. It doesn't matter which one comes first. And I'm going to show you why, because what you're saying I should have done, and I'm glad you saw this, and I'm glad you understood when I said I will have students that say I did this wrong, because they'll go, but Mr. Orris, the formula is y2 minus y1. Well, it doesn't really matter. If I take the second coordinate, put negative 2 here, minus 0, over 3 minus negative 1. If I swap, which point comes first? Does that make a difference? Well, I have negative 2 minus 0. Anything minus 0 is that, so I get negative 2. 3 minus negative 1, well, that's the same thing as plus 3 plus 1, which is 4, which reduces to negative 1/2. It doesn't matter.
I have a question.
Yes. Hang on just a second. I know your question. Just a second. Okay. It doesn't matter. It doesn't matter which x coordinate comes first, which y coordinate comes first. It doesn't matter which point you pick to put in the front, because I swapped them. And look, I got the same thing. Here's what does matter. These 2 points line up vertically. Okay? Hang on. These 2 points here, they line up vertically. That's what counts. That's the important thing. Okay? I am just a second, just a minute. Just that in a second. Okay. Any questions other than about the paper? Okay.